Okay, so same question number 4a, and we're now going to use the gamma distribution to solve for this probability. So the probability that we are after is 2 failures again. If you haven't seen the first video where I've used the Poisson distribution, please go back and see that one, followed by this one. Okay, so 2 failures in 30 kilometers, and we had done that as a Poisson distribution in my first solution. We can also define a random variable x, and this will be defined as the distance until the second failure. Okay. So either the time or distance until kth or the rth occurrence fits the definition of a gamma distribution. Okay. So x here has a gamma distribution. And for gamma distribution, again, we need a lambda, or lambda for 30 kilometers. And in the previous solution, guys, I talked about why lambda, or the failures per kilometer, was equal to 0.0083341. Okay, so 2 failures in 30 kilometers is equal to the probability that the distance until the second failure occurring is less than or equal to 30. Okay. So this means that if I were to draw a diagram here, if this is 30 kilometers, and obviously this is 0 kilometers. If we have 2 failures in 30 kilometers, it means that both of our failures occur between 0 and 30, which is same thing as saying that the distance until the second failure is going to be less than 30 kilometers. Okay. Now there's 2 ways of computing this. One, using the Poisson method, and 2, using the gamma integral approximation. So the Poisson method is this is equal to the complement of x being greater than 30. And x being greater than 30 means that it is a probability that there are less than 2 failures in the first 30 kilometers. Okay. So again, what this means is the distance until the second occurrence, okay, is greater than 30 kilometers, which means that the second occurrence happens somewhere after 30 kilometers, which in turn implies that in the first 30 kilometers there's either going to be 0 failures or 1 failure. So this is 1 minus the probability of getting 0 failure or getting 1 failure. These random variables now are discrete. They're the number of failures per 30 kilometers of distance. Okay, so these guys are Poisson now. Okay, so those probabilities are going to be 1 minus the probability of 0 failures. Let me write that as an equation here. E to the minus 30 lambda times 30 lambda to the power of 0 divided by 0 factorial plus e to the minus 30 lambda to the power of 1 divided by 1 factorial. Sub in the lambda that we have here, okay, into all of these lambdas. Okay, and solving for this, I trust that you guys all know how to solve this. We end up with, let's see, let me give you one intermediate step here. 1 minus 0.9735. which yields a probability of 0.0265. Now, this can also be done using the gamma function method, which I'm going to display here. Okay. So let's take a look. So this probability here, the probability that we are after, is equal to, let's see, where's my solution? Will be equal to the integral from 0 to 30 of f of x, where f of x is the PDF of the gamma distribution, dx. And we said that this guy is equal to 1 minus gamma of 2, where 2 is our 2 here, usually denoted by either r in the course booklet or k, times 30 lambda, the average number of occurrences in our time frame, and our time frame of interest here is 30 kilometers, divided by gamma of 2. Compute this, and we get 1 minus gamma of 2 comma 0.25023. Again, this lambda here, we use 0.008341. Divided by gamma of 2 is simply equal to 1 factorial. And 1 factorial is simply equal to 1. So gamma of 2 comma 0.2503 can be found on the incomplete gamma function table. Okay, so look for the gamma 2 comma y, and our y value is obviously in between 0.24 and 0.26. So it has to be a value between 0.9754 and 0.9715. So do a linear interpolation, and I have interpolated that, and interpolating we end up getting gamma of 2 comma 0.25023 is equal to, where's my interpolation, 0.9734 over 1 factorial, which is simply 1. And computing this probability, we get 0.0266. Okay. As you can see, the Poisson way and the gamma function way should yield the same answer.